Good morning. So I hope everyone's doing well. I miss seeing your beautiful faces. I had a nice spring break, got some things done around my house. Not too many of those, kind of relaxing. And am ready to get back at it. All right, so today we're going to do elimination to solve a system. Again, a system is two variables, two equations, and our goal is to find an x and a y that work in both equations. So the extra layer we're talking about today is when you look at your problem, like if you were to look down here, I do not have the same numbers in front of the x or in front of the y. So that is a problem. That's what we're going to think about today when we're doing our problems, is this second step. If you need to multiply one or both equations by a constant, you will do that in order to solve it. So there's an extra layer. That's the extra layer that we're going to have to do a little multiplication. All right, so here is our problem. And if we look at that problem, again, I don't have the same number in front of the x's. I don't have the same number in front of the y's. So I'm trying to get the same number with different sides. And I'm really looking for a multiple that they both divide into. It's almost like when you're looking for a common denominator. That's the same idea that's going through my head. What do 3 and 8 divide into? 24 is the lowest number that they divide into. It's the least common multiple. What do 3 and 6 both divide into? 6. So that one's easier. I would choose to get rid of my y's and get the same number in front of my y's because I already have a 6 here and they're different signs. So I'm going to multiply this first equation by 2. And I chose 2 because 2 times this negative 3y will give me negative 6y. When I do that, I have to multiply everything here. So I'm going to multiply 6x minus 6y equals 42. Now, if I add these two equations together, the y's will be eliminated. That's why it's called elimination. So I get 14x equals, I think this is 28. And then I can easily solve this equation in one step. I just divide both sides by 14. And I have x is equal to 2. Same as we always did. Once we know one variable, just go up into one of your equations. It doesn't matter which one you go into. It has to have two variables. And find the other one. I'm just going to go in this original top one. So I'm going to say 3, and I know the x value is now 2, minus 3y is equal to 21. So I get 6 minus 3y is equal to 21. I'm going to subtract 6 from both sides, and I'm going to divide both sides by negative 3. And I get negative 5. And so then I say 2 comma negative 5. And that is my solution. And again, you can plug it in and see if it works. 3 times 2 is 6. Minus 3 times a negative 5 would become positive 15. 6 plus 15 is 21. 8 times 2 is 16. And then plus 6 times negative 5 is negative 30. 16 plus negative 30 is negative 14. So I know it works.